I already introduced how can we just get the inverse trigonometric functions. We can just retrieve the domain to let the functions with having the property of 1 to 1. Then we can say, okay, it's because it's a 1 to 1 by that domain, then we can say its inverse function exists. Then at that time, I also show you 5 inverse trigonometric functions, right? Then I also show you some property about it. And then we just learn how to get the derivative of the inverse trigonometric functions. And especially, we just focus on arcsine, arctangent, and arcsecant. And through the support from the series in the first section in chapter 7, we can get, when we just differentiate inverse arcsine x, then we can get the result is just like this one, right? And don't forget, we need to retrieve the domain to some certain range, like this one. For the arcsine x, we need to retrieve the x is larger than -1 and less than 1. And we also learn that when we just want to get the derivative of arctangent, the result will be like this one, 1 over 1 plus x squared, right? Without any restriction on x. All of x from negative infinity to positive infinity, all of x can meet the requirement. Okay, and then we also learn this one for the arcsecant. If we want to get its corresponding derivative, it will be divided into 2 parts. One is larger than 1 and one is less than -1. Or we can have the unique one for each one by using the absolute value of x. Okay, and for the rest 3 ones, actually we also can simply use this property that arcsine x plus arccosine x is equal to 1/2 pi. So that with this, then we can easily to get the derivative for the arccosine. Actually, the only difference between the derivative for arcsine and arccosine, it will just, the only difference is the negative, the sign here. Okay, so similarly, we can have the rest 2 ones. So in total, we already know these 6 functions antiderivative. Then I just also spent several minutes to get this integration formula. And later I will show how can we just get this one. But you can see actually these 3 ones come from these 3 results. The first one is this one. So as I told you that when we differentiate arcsine x, we can get this one. But you need to think in the opposite way, that if we just differentiate it, we can get this one. But let's just think about in opposite way, that when we just integrate this one, then we can go back to get this one. So similarly, if I just integrate 1 over 1 plus x squared, actually the result should be arctangent. So this part is somehow different from what we learned in last semester. In last semester, when we just encounter such this one, we will try to use u. We try to use u to replace 1 minus x squared, then try to use the substitution rule to integrate it. But anyway, after you learn this, if you just phrase the problem to integrate 1 over square root of 1 minus x squared, actually the result will be this one. So no matter how you substitute the complex form, actually you cannot get the correct result. So that's why I just want you to pay more attention about the integrate with this form. Okay, so today I will show you how can we just get these 3 ones, and then how can we just apply these 3 ones to calculate some integrate of some specific form. Okay, so this is just what we just learned on Monday. So today I will show you how can we just get this one. Then, okay, I can give you, I can show you the first one. How can we just get the formula? So because as we already know that when we just differentiate x sine x, x sine u, we already have the result is 1 over square root of 1 minus u squared du over dx, right? We already know that. And especially we need to retrieve the u's range is larger than -1 but less than 1, right? So we already know this one by the previous part. Then can we just let u is equal to a v over a? So you can see u and v, the only difference is u is equal to v over a. So you can see it's just like, you can regard v is a times u, where a is a constant. But u and v both are differentiable functions of x, okay? But a is constant. So where a is a constant, so let's just replace it again. That okay, sine x sine u here will be v over a, right? So series one, you can just replace u with v over a. Then follow this formula. It should be 1 square root of 1 minus, okay, we see u here, so it should be v over a squared. Then du dx, so u again, it should be v over a. Okay, so I just simply replace u with the form of v over a. So you can see we will not see any u in the new expression. Okay, and then we can continue to do that. That it will be 1 square root of a squared minus v squared over a squared, right? Here I can convert it into this one. Then here, because u is a differentiable function of x, so we still can keep dv over dx here, but we just move the constant 1 over a out of this expression. Then you can see this part can be cancelled by this one. Because we can just move 1 over a square out of the square root, so then we can get the same 1 over a here, so we can cancel them together. So finally, you can see the result is 1 over square root a square root of a square minus b square, then dv over dx. So please just pay attention to here. Pay attention to here to here. Right? So if we can have this one, then you can see we can get, so that we can get, when we just integrate 1 over square root of a square minus v square dv, it will be arcsine of v over a plus c. So it's an indefinite integral, right? Let me just emphasize that again. When you just differentiate this part, you can get this one. So that means if you just integrate this part, and then you can get back to this one. Okay, so then we can have this one. So if you focus on this one, you can just go back to this one. So that's why we can get this formula. That's why we can get this formula. So following the same way, you can get these 3 formulas. That I say that when you just see the expression about the integration, the differentiation, then you need to think in the opposite way. You can get the integration form. OK， 所以这边很快带一下，就是说，如果你可以得到这个微分是这个样子，相对的你就可以得到这个，对不对？因为它只是一个反运作嘛，微分跟积分是反运作。如果你可以微分它，可以得到这个，相对的你可以积分它得到这个。那这也是为什么我们会得到这个公式的原因。那大家不要在意这个哈，这些写 v 的部分，虽然跟我礼拜一上课的时候写 u， 事实上是没关系的。为什么这个 u 呢？基本上它是一个x 可微分的函数而已哈，所以你用 v 也好，用 u 也好，事实上都是同一件事情哈。Okay, so we will try how to apply these 3 formulas. So the first one is when we just want to integrate this one. If you want to integrate this one, okay, if you just follow the knowledge you just learn last semester, the tuition way for you is, okay, you will try to replace this one. For example, I just let u be 3 minus 4x squared. Then you will immediately calculate du over dv dx, right? Then I can get negative ax. Then in the past, you will try to, okay, replace this one by dx is equal to du over negative ax, right? Then you will use this part to replace this part, and you will say this part is u. Did you find something wrong? If you just follow this way, I mean follow the substitution rule, you just learn last semester, you will find that, you will suddenly find that if I replace dx with du over negative ax, you can see I cannot completely replace all of x. you still keep x here, right? So you can see if I follow this way, you will get this one, then over square root of u. So you still have this one, right? You still have negative ax. So you cannot completely let the expression just be in u, because I will still have something related to x. So this way is the wrong way, right? So in the past, maybe if you just see this expression, you will follow this. 在上学期我们学过那个代换法的时候，我们通常有一个惯性是看到根号里面叭叭叭的东西，就想办法换。可是你要记得，这样换下来是不行的。换完之后它没有很干净，它还有残留 x， 你这 x 越换越糟糕，式子可能会越换越糟糕，到最后它没办法换。所以这个是一个非常重要的一个计分技巧，但是在这里是用行不通的。Okay, so then if this way doesn't work, and then we should think about that we just let a is equal to square root of 3, then u could be 2x, because then we can have du over ds is 2. Then we can have ds is equal to 1/2 du. So we can just replace, we can just use this one to replace dx. So then we can have 1/2 du, right? Because here is dx. So I just use 1/2 du to replace dx. Okay, then we will have, since a is square root of 3, so then we can have a square minus u square. We can just replace square blah 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 into square a square minus u square. So did you find that it will be 1/2 integrate du over square root of a square minus u square? So the result will be 1/2 arc sine u over a plus c, right? Because we just learned that from here. From here, you can see if you just encounter, try to integrate 1 over square root of a square. A here is constant. V is a variable, or somehow it should be a function, a differential function of x. So the result will be arc sine of blah blah blah, right? So just follow this one. Let me just make it smaller. We can have a matching here. You can see this is a square minus v square is u square, and the result will be this one. Okay, so you use these two ones to replace the a variable and u variable. Remember, don't let it back, let them back. So the result will be, the correct result will be 1/2 arc sine 2x over square root of 3 plus c. Okay, I will show you a second example. Is that okay? Let me just show you a second example. That if I ask you to do this one. So I believe you may just follow a very intuitive way to replace this part by u. But actually it doesn't work again, it doesn't work. But follow this. Actually, there is also some tip that you should regard this one by 4 minus 4 plus 4x minus x squared. So I just add 4, but to keep them consistent, I need to add minus 4 there, so that we can just cancel these two 4s, then go back to the original form, right? But with this, then we can have four minus s minus 4 minus 2 square, right? Because this will represent a complete square, 完全平方, right? So then you can just think about that. If I just let a to be 2, then u to be s minus 2, then you can see it will become integral du over square root a squared minus u squared, right? Because you assign a to be 2, then you also assign u to be x minus 2. So once you assign this one, remember you need to calculate du over dx, right? So it's quite simple. Du over dx is equal to 1. So that means du can just replace dx. So we can have dx du then over square root of x squared minus u squared. So the result, just follow the formula. Then the result will arc sine of u over a plus c. So it will be arc sine u with that x minus 2 back to u, then 2 go back to replace a, then this is the result plus c. And don't forget, we need to restrict this one, taking the absolute value of x minus 2 over 2 less than 1, so that we can have s minus 2, taking its absolute value should be less than 2. Then finally we can have this one. Then we can see x should be restricted within 0 to 4. So don't forget, you can have this result. But don't forget, you still need to follow the restriction about its domain. Okay? So when you say integrate it, don't forget your x should be restricted, because we need to keep it 1 to 1. And especially when we differentiate, we cannot allow the differentiation value is positive infinity or negative infinity. OK， 这边从这一题呢变到这一题呢，差别在哪里呢？这一题呢，一样你看到这个根号 4x 减到 x 平方，过去你学的 substitution， 你这种惯性的就会想 u 去代换它，你会跟我遭遇到这边的情况是一样的，换得不干不净，所以这时候就不要往 substitution 去想了，反而去想这3个公式刚刚学到这3个公式，有没有办法去套出这3个公式呢？去得到是往反三角函数的角度去想。 哦。那如果可以套成功，就可以到右边来。那到右边来的条件里面，不要忘了它也有这些定义域的局限的问题，还记得吗？我们当初在讲反三角函数的时候，基本上要让它有1对1，事实上我们是要做一些限制的，对它的范畴做一些对它定义做一些限制的。所以经过这些限制搭配，结果是这个的话，这2个条件要同时写。好，所以刚刚这个题目，我再举另外这个例子的原因就是看到这个式子啊一样的，不要误以为是 substitution。再来这边又有用了一个很特殊的方法，它是用了配方法，让它配成完全平方，对不对？然后配完之后，你就会有这个样态，有这个样态你就可以朝这个公式走，最后觉得的答案是这个。但是不要忘了，这个答案的结果的背后呢，它必须要符合它的绝对值要小于1。逗出来哦，原来你的 x 啊，只有在介于0到4的时候，你这个的积分才会等于这个。所以这两个缺一不可哈。你有这个结果的同时，背后隐含着你的 x 要做这个限缩。Okay, so it's almost at session 6. Then we will move to session 7. For the session 7, we will talk about the hyperbolic function. This session is very similar to session 6. Hyperbolic function, we will face 6 functions, just like when we just discussed trigonometric function, we will face 6 trigonometric functions. But for hyperbolic function, we also need to face 6 hyperbolic functions. And the concepts used here are very similar to the concepts in section 6. So this part I will go a little bit faster. And then after this section, we will hold our first quiz. Because as I told you, I will have a business trip to Vietnam. So on the week of March 9, 10, or 11, I forgot. But we will formally announce the scope. 11, right? 10. Okay. So March 10, we will hold our first quiz. The scope will include session 3, session 5, 6, 7, and 8. Not that large. So I hope you can just keep the chance to get a good score. Normally I cannot expect too much for the midterm exam, and especially for the final exam, because the concept will become harder and harder, and that means the problem, the questions will become tougher than the one in the early sections. So I hope you can just keep the chance to get a good score. Okay. So but later on, I will formally to announce it. But in the same week, for the lecture on Thursday, I will come back. I will come back on Thursday very, very early morning, because I also need to host a very important meeting in our college. So for the lecture on the same day, it's no problem for me. OK， 我3月10号那一周刚好要带院的几个老师去拜访越南2个蛮重要的大学所以那一周的10号呢，就 之后，我们就把它变成小考。那小考的范围就是7之3、5、6、7、8、6、7、8，对，哦，范围不用很大，所以希望大家好好把握这个机会哦。那正式的那个范围也好，还有那个时间，我都会跟。我唯一担心的是，我们这次人很多，我不知道到时候这个位置恐怕是不太够的哦。不过这个可能到时候我再请助教注意一下哈。那接下来我们就要讲这个第7节哈。那第7节我会讲的稍微快一点点，因为它其实很多观念，你如果仔细去看第7节，这个章节东西很多哦。但是我讲快一点，是因为它观念跟前面所学的第7至6所学的很雷同哦，所以可能动作如果有些快呢，就请大家要去回想我们在第6节所学到的东西啊。Okay, so when we talk about hyperbolic function, we will just define it first. So every function f, if it is just defined on an open interval, can be centered at the origin. Center and origin. So the interval should be symmetric. Okay? Center at the origin means from negative A to A, like negative 5 to 5, negative 100 to 100. It's a interval centered at the origin. Can be expressed by f of s is equal to you can see this is a little bit trivial, right? Because this term can be cancelled by this term, right? Because this is positive f of negative x minus f of negative x. So these two terms can be cancelled. And then one half, then we can complete one. Okay? But once we define this, then we can assign this part is an even part, and this part is the odd part. So a typical example for this is exponential function. Did you remember exponential function is defined from negative infinity to positive infinity, right? Exponential function. So it meets the requirement for the interval centered at the origin. Okay, so we can define it as e to the power of x plus e to the power negative x plus e to the power x exponential function minus e to the power negative x. Then for here, we will say this part is a hyperbolic cosine. And this part, we call it hyperbolic sine function. So normally, when we just write down, we will write as hyperbolic sine. So you can see hyperbolic sine. We just add h, this character between sine and x. This is hyperbolic sine. So we also have hyperbolic cosine. Also add h here. And then we also can define hyperbolic tangent x. We define it as according to the hyperbolic, sorry, maybe it's hyperbolic sine. Okay, so it will sorry, I just make the wrong sequence. Here should be, sorry, wait, hyperbolic cosine. Sorry, let me correct it. Hyperbolic cosine, hyperbolic sine, then x. Okay, yellow. Okay, sine, cosine, right? Then we just define hyperbolic tangent, just like trigonometric function. It should be hyperbolic sine divided by hyperbolic cosine. So the result will be e to the power x minus e to the power negative x over e to the power s plus e to the power x. Okay, so you can just follow the same way to define hyperbolic cotangent and hyperbolic cosecant, then hyperbolic secant. Okay, so in total, we also have 6 hyperbolic functions. Talking about its curve, then we can see if we want to know its curve, then we can simply just using these two curves, added together and divided into 2. So you can see for the hyperbolic sine, it will be, okay, so you can see here, this is e to the power of x, then this is negative 1/2 e to the power of negative x. So when you just add them together, then you can get the hyperbolic. This is a hyperbolic sine x. So you can just follow the same way. You can get hyperbolic cosine. Then this is hyperbolic e to the power 1/2 e to the power x, right? Then we also can get 1/2 e to the power negative x. Then if we just add them together, here, add this one, and then finally will be here. So finally we can get the hyperbolic cosine, like this one. This is a hyperbolic cosine x. A little bit complicated. Not like sine, cosine is a periodic function, right? But for hyperbolic sine, hyperbolic cosine, hyperbolic sine is an odd function. It's an odd function. And hyperbolic cosine, it will be even function. It will be even function. But when you just divide these two functions together, then you can get hyperbolic tangent. I will ignore this part. And then, okay, maybe I can show you together with the hyperbolic cotangent. So hyperbolic sine, hyperbolic cosine, cotangent should be hyperbolic cosine over hyperbolic sine. You can see very similar to the rule for the trigonometric function. When we just learn about tangent function, then we know tangent x is equal to sine x over cosine x. When we learn about cotangent function, we know it should be cosine x over sine x. So for the 6 hyperbolic functions, they have similar relationship among these hyperbolic functions. So let me just show you these two figures for you that okay, it will be like this one. Then this is hyperbolic tangent. Then there is hyperbolic. Is very, should I say, it's very weird. But actually, if you just follow the definition, you can draw it just like this one. This is a hyperbolic tangent. This part is also part of the hyperbolic tangent, but they are separate. Okay, but for the hyperbolic tangent x, it will be like this one. It's also symmetric at the origin. Okay, so we have these two ones. Then when we talk about the hyperbolic second x, so following the rule, it also should be 1 over hyperbolic x. So it will be 2 over e to the power x plus e to the power negative x. So if we talk about the hyperbolic cosecant function, it will be 1 over hyperbolic sine x. Then it will be 2 over e to the power of x plus minus e to the power of negative x. So if you want to draw it, you can get this is as this y, then this is 1, this is the limit, then you can get, actually this is y is equal to hyperbolic second function. Then if you try to draw the hyperbolic cosecant function, then the result will be like this one. Okay, I hope you just have some image about these 6 functions, but if you have some time, I encourage you to try to figure out why the figure will just look like this one. Of course, right now you have your smartphone. Of course, you have some website. They can help you. They can help you plot the curve for these 6 functions. But if you just go back to its very origin definition for these 2 functions, you can see all comes from these 2 functions. Okay, all these 6 functions come from these 2 functions. 虽然这里有6个，其实也不好记了哈，跟三角函数一样，越后面就越难记。但是保持一个原则，它的出发点都来自于这2个，都来自于这2个。那特别要记得，请大家特别记得 ，hyperbolic sine 是这边是减号 ，hyperbolic cosine 是加号，然后后面的原则全部都 follow 6个三角函数的原则哦 ，tangent 也好 ，cotangent 也好 ，secant、cosecant 都一样。只是对你来讲呢，或是对我们大家来讲比较困难的是什么？就是画这个图了哈，因为这完全没有一个，不像那个6个三角函数，它都是一个周期性函数，每个拍或每个2拍，它就会有一个重复发生的动作，可是它没有。Okay, so following these 6 functions, did you also image that we need to face its inverse function? We also, if we already have its inverse function, then do you think about its derivative, its corresponding derivative? 我讲说，大家看完这6个，有没有接着想到，如果它要有反函数呢？哦，开始傻眼了，对不对？开始傻眼了。OK， 原则都一样。记不记得前面在讲那个的时候是，如果它不是1对1，就想办法把限制到变成1对1。所以这6个函数里面，有些人已经1对1了。哦，打个比方 ，hyperbolic sine function is already 1-to-1, so you don't need to set any restriction on it. Then you can directly get its inverse function. However, just like this one, hyperbolic cosine function, you can see it's not. If we just follow the original domain, actually it is not a 1-to-1 function. So you need to set some restriction on its domain, then you can have 1-to-1. Then if you have 1-to-1, then we can have its inverse function. Okay? Okay, once we have 6 inverse functions, inverse hyperbolic function, then we need to start to think about its derivative, right? How can we just get its corresponding derivative? Then if we can get its derivative, can we just get its opposite relationship? Like, as I told you, that if I can differentiate someone to get someone, then can we just follow the opposite direction? We can get its integral form, just like this. Right? Just like in the beginning, I told you that if you know the differentiation form, then we also can get its integration form, right? So we just finished the session 7. Okay, actually, okay, I just give you the direction, but I still will teach you step by step. So okay, right now we already know these 6 functions, right? So just like, can we try to get some relationship among these 6 functions? Like if we calculate 2 times hyperbolic sine x times hyperbolic cosine x, what will happen? It will be 2. Just go back to its original definition. It will be e to the power x minus e to the power negative x, 2 times e to the power x plus e to the power negative x over 2. So then we can get 2, then we can have e to the power of x squared minus e to the power negative x squared, right? You can see a plus b times a minus b, that will be a squared minus b squared. I believe you also learn this formula, right? Then we can get 2 e to the power 2x minus e to the power 2x. How is that? It will be hyperbolic sine 2x. So we can just versus. Did you remember sine 2x is equal to 2 sine x cosine x? So sometimes I say it's 这6个就像那个三角函数的山寨版。大家知道山寨版长得很像，它有很多相似的关系，有没有？这个是什么？三角函数的2倍角的关系，有没有 ？sin 2x， 它也有 hyperbolic sine 2x is equal to 2 times hyperbolic sine times hyperbolic cosine. So I also did some relationship for you that you can also find that hyperbolic cosine square x minus hyperbolic sine square x is equal to 1. So did you remember we also have sine square x plus cosine square x, it will be 1. So a little bit different, right? Here is minus, but here is, this is subtraction, this is addition. They are different. But you can see this is for hyperbolic function, but this is for trigonometric function. So then we also have some other relationship like hyperbolic square x plus hyperbolic sine square x is equal to hyperbolic cosine 2x. Then we also have like half angle expression. Then we also have this. So a lot of, right? So I also can show the relationship between some trigonometric functions, like we have 1 plus tangent square x is equal to secant square x, right? So I just, this name here is just for your reference. Try to compare the relationship between trigonometric functions and try to have some relationship, find the relationship among these hyperbolic functions. Okay? So there are several. So I hope you can just check them out by yourself. Okay, then we will take sorry. Okay, then we start to think about its derivative. Its derivative. But before we think about its derivative, I believe I need to show you the inverse. Oh, no. We still go back to its derivative. And integral. So when we differentiate hyperbolic sine x, so it will be differentiate e to the power of x minus e to the power of negative x over 2, right? So when you just encounter hyperbolic function, sometimes the best way is just go back to its original definition. E to the power of x minus e to the power of negative x over 2. Then when you just differentiate it, you can get, it will be e to the power of x minus negative e to the power of negative x. Right? So it will be, so what is this? What is this? Hyperbolic cosine, right? So did you try to think about when you just differentiate sine x, then you still can get cosine x, right? So follow the same idea when you differentiate hyperbolic cosine x, then you will deal with this one. Then it will be e to the power of x minus e to the power of negative x. Then it will be simply hyperbolic sine x. So just also make a comparison. When you just differentiate cosine x, it will be negative sine x. So different. So that's why I say they are quite similar, but actually they are still not the same, right? You can see here, when I differentiate sine s, we can get cosine s, but we differentiate hyperbolic sine s, we can get hyperbolic cosine s. But when we differentiate cosine s, we can get negative sine x. But when we differentiate hyperbolic cosine s, we just get positive hyperbolic sine x. Okay, so for the rest ones, you can get when you differentiate hyperbolic tangent x, then you can get this one. And then you differentiate hyperbolic cotangent x, it will be this. Also very similar to the trigonometric function. Then 5, when you differentiate hyperbolic secant x, then you can get negative hyperbolic secant x times hyperbolic tangent x. Then 6, and you can get hyperbolic cosine x times hyperbolic cotangent x. Right? So for you study here, the only way is just go back to its original definition, then try to differentiate it, and you can see they also have some similar relations among the hyperbolic function group. Just like when you just deal with when you just follow the same operation in the trigonometric function group, you can see they are almost the same. Okay, so let me just give you some example that, okay, if I ask you to calculate integrate from 0 to ln2 for e to the power s times hyperbolic sine x. Okay, you can see this is e to the power s, is a typical exponential function, but here is a hyperbolic function. Again, just go back to the original definition. So you can convert it into times this one. Okay, then the calculation will become simpler because the form has been reduced to this one. Then it's just simply you can just simply put because the exponential, when we just integrate exponential function, the result is still exponential function, right? So finally the answer is not that hard, something like that. Then also, if you want to differentiate hyperbolic tangent of square root of 1 plus t squared. So don't forget, you still need to regard here as u, right? So that will be outside inside function, right? We need to differentiate the outside first. So when we differentiate the outside, then we can get hyperbolic secant square, blah blah blah, right? Then the blah 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 should be this one. Then we need to add okay, so it will be 1/2 to the power 1/2. Then just try do the chain rule again. Then you can see this one. Then finally, the result will be maybe we just go this way, go for this part very is a little bit faster than before, but you just keep the original process, then you still can deal with these functions, even though they are hyperbolic functions, right? 所以在处理这个 hyperbolic function 的时候，其实也不用太担心。为什么？因为它其实还是源自于这个exponential function 的一些运作哦。所以如果你遇到这种也不用担心，这怎么积分呢？这个回归到它原来的定义，回归之后它原来的 exponential function 把它简化之后，事实上就不难了。那微分也是一样的，虽然这看起来很丑但是就维持我们上学期所学的这个函数呢，就是你像圈入耳也好，或者是什么 outside inside function 的概念也好，外面的先微分所以先把里面的先隐藏起来不看，这里面先不看，对外面先微分。所以我们刚刚已经学到 hyperbolic tangent 的微分呢 ，hyperbolic tangent 微分是 hyperbolic secant 的 square x， 所以这边是 u， 所以记得这个保持 inside 之外，对这个 inside 还要再多挂一个微分。那微这个分呢，又要一次，这是负的1/2次方所以微分出来它又有负的1/2的负1/2的负1/2次方的这个形式，在对里面再微分一次。所以其实它只不过是多了所谓的 hyperbolic function 在这里面做运算而已，但是所有的原则跟上学期所学的一模一样Okay, so let me just show you the last one. It's also simple. That even though we have square here, so if we just have a square here, you can just go back to the formula here. Square is here, right? Square. No, not this one. This one. Okay, it should be hyperbolic cosine 2x minus 1/2. So you can see here, it will become integral from 0 to 1. Hyperbolic cosine 2x minus 1 ds. And it will become this one. Because when you integrate hyperbolic cosine, you can go back to get hyperbolic sine. But don't forget the coefficient. Okay? And then finally, through some calculation, you can get this will be hyperbolic 2/4 minus 1/2. So maybe a little bit faster, but just remember, make good use of those formulas related to the hyperbolic functions. Then also remember, when you say integrate hyperbolic cosine, you can get hyperbolic sine. When you integrate hyperbolic sine, you can get hyperbolic cosine. Because we have these formulas. So when you differentiate, you can get this one. Don't forget the opposite direction. When you integrate it, you can get this one. Like this. If I ask you to integrate hyperbolic secant square x, don't forget it should be hyperbolic tangent. So when we learn these 6 formulas, don't forget the opposite direction. Don't forget when I ask you to integrate this part, that will go back to this one. Okay? So far we already know what these 6 hyperbolic functions. And right now we know how to differentiate these 6 hyperbolic functions. Then if Yes. Sine， 这是 hyperbolic sine。square 二次方。黄色的哈，有写错吗？呀，OK hyperbolic sine。这个到时候讲的非常的，后面还会有这个 hyperbolic sine， 等等我们要讲 inverse， 对不对？是不是讲 arc？ 然后 arc 完之后，我们还要微分，整个念起来变成什么 ？differentiate arc hyperbolic sine x， 每一个都要变成讲的很长了哈，所以有时候漏掉是 h 哈，谢谢。So let's continue to focus on the inverse hyperbolic function. So I will show you first that the first one, when we talk about hyperbolic sine function, the original definition for the domain, the definition for this domain is negative infinity to positive infinity to negative infinity to positive infinity, right? I show you the figure here. Here, right? This is hyperbolic sine. So let me show you the hyperbolic sine. The original one is this is hyperbolic sine x. So if we want to get arc hyperbolic sine x, we just change, right? We just change this one. Domain become range become domain, but luckily it's the same. But the curve will be different. Curve will become, this is y is equal to arc hyperbolic sine x. This one is simpler, but how about hyperbolic cosine? Hyperbolic cosine, the original definition is the curve will be x, y, and the curve is something like this. So this is the original hyperbolic cosine function, right? But is that one-to-one? No, right? So it is not one-to-one because when we just put a horizontal line here to check, we can have two intersections. So it's not one-to-one. So we must set some restriction on this. So we just focus on this one. So that our definition will be restricted from negative, original it should be negative infinity to positive infinity to map to from 1 to positive infinity, right? But it is not one-to-one. But follow this way, not one-to-one. So we must have some restriction. We need to restrict it to become from zero to positive infinity. Then map to one to positive infinity. So that once we just change the direction, once we want to get hyperbolic cosine x, then the curve will be like this. So when we focus on this one, the domain will become from +1 to positive infinity to map to 0 to positive infinity. Because this is domain for the original function, then it will become a range for the inverse function. Range will become domain. And then the figure was just like this one. Did you remember it will symmetric by y is equal to x? Did you remember? But I told you that the original function and its corresponding reverse function will be symmetric on y is equal to x. 原来函数跟它的反函数，它会对称于 y 等于 x， 对不对？所以我们为了1对1，我们只保留这一块。为了只保留这块，我们的定义域就会从负无穷大到正无穷大呢，变成0到正无穷大，但它的值域不变，还是从1以上，对不对？所以反过来，在这样的限制的条件下，有了1对1，我们转成这样子之后就是1对1了 ，1 to 1。Then of course we can have its corresponding inverse function for the hyperbolic cosine function. Then we can have this one. The curve will be this one. Okay, so let me show you. So of course we still have hyperbolic tangent, hyperbolic cotangent, so that we have arc hyperbolic function and arc hyperbolic cotangent function. Then I will show you the last one, hyperbolic second. So when you just draw the hyperbolic second function, the function will be this one. This is y is equal to hyperbolic second function. So maybe next time when I talk this part, it will be a little bit, it was a little bit faster. So this is a hyperbolic second, right? So again, this figure is not 1 to 1, right? So its original, so we need to retreat its domain from to negative infinity to positive infinity to 0 to positive infinity, then map to 0, not include 0, but include 1. The endpoint is 1. So we will focus on this part, right? So this part will have 1-to-1 property. This part will have 1-to-1 property. So if we talk about y is equal to hyperbolic second arc hyperbolic second function, then the range, the domain will become from 0, not including 0, to 1, including 1, mapped to 0 to positive infinity. So the curve will be something like this. This is 1. So again, they will just symmetric to y is equal to x. So this one will be hyperbolic arc hyperbolic x. Okay, then the fourth one I want to show you is this property is very important. Actually, hyperbolic x is equal to hyperbolic cosine over 1 over x. This property is very interesting. Did you notice that when we talk about hyperbolic second function, it will be 1 over hyperbolic cosine x. So when we talk about its arc, then its arc, the relation in between is s here will become 1 over x. 我这边用很快解释一下这个结果，我等一下会学为什么会这样子哈。但你们发现这个结果好有趣哦哈。这两个 hyperbolic second function 没有这个 arc 哦，没有这个 arc 哦，没有反函数的时候 ，hyperbolic function 其实是 hyperbolic cosine function 的导数。当我们讨论它的反函数的时候啊，它竟然刚好等于 hyperbolic cosine function 的反函数，但是里面刚好带导数。哦，不要被这个符号给混淆了哈。如果没有这个的时候，没有这个 up 的时候呢，它们两个刚好是相比好的，而且是 x 而已。可是如果有这个 inverse， 它竟然会刚好是它的里面带的是导数的东西。好，这个结果同样用在 hyperbolic cosine 或者 hyperbolic cotangent 那我证明为什么是这样哈。So let me just give you a note that actually we know hyperbolic second function is 1 over hyperbolic cosine x, right? This we just learned by the definition, right? So how can we prove it? Hyperbolic function, hyperbolic second function, when I use it to composite hyperbolic arc hyperbolic of 1 over x, how will happen? If the result can be x, that means this one, composite this one, can be identical function. Did you remember when we just talked about the original function, composite, inverse function, we can get identical function, right? When we use inverse function to composite the original function, then we also can get identical function. So if I try to composite it, then the result can be identical function. Then I just suddenly find the inverse function. Why? Because we just learned that if the function can have an inverse function, the inverse function will be unique. 还记得吗？我们在说一个函数去合成另外一个函数，如果可以乘到 identical function， 当它是一个一对一函数，它有一个反函数的时候，它去合成这函数会变成 identical， 这个就是它的反函数。你会说搞不好有其他的，不会，我们之前证明过了，一旦你有反函数，你就只有唯一一个反函数。所以当我把它整 composite 在一起的时候，会得到 identical。那 bingo， I just got its inverse function. Okay, so we are trying to do this and see if the result will be x. So let's see why. Because the hyperbolic second function will be hyperbolic cosine 1 over hyperbolic cosine x, right? Then right? Because hyperbolic second function is equal to 1 over hyperbolic cosine function. So hyperbolic function will be 1 over hyperbolic cosine function of blah blah blah, right? So blah blah here. Let's simply put it here. Then you can just focus on here. You can see this one is inverse function. So original function composite is inverse function. It will just simply identical, right? The identical is 1 over x because 1 over x is input. So 1 over x. So okay, we just get x. So that means when we use this one to be composited by hyperbolic second function, that we can get this identical function. Then we just suddenly find it is arc hyperbolic second function. Okay, so similarly, if you just follow the same way, you can get that. You can for the same For the same idea, you also can get 5 that hyperbolic cosecant function s is equal to hyperbolic sine hyperbolic sine of 1 over x. Then follow the same rule, you can just get these two ones. So you can finally also conclude these two properties. Okay, for the next part, we will talk about the derivative and integrals. So maybe I just leave this part to next week because I need to rush for. Actually, I will be late already because the get together will be held starting by 6 p.m. But it's okay. But I'm afraid we just stop here. We need to stop here. Then next week, next Thursday. So don't forget, next Monday, we don't need to come to the school. Do you know that? 下礼拜不用来上课，知道吗？因为那个今年的那个校庆的